Welcome to SSR Pharma Media, your trusted source for pharma knowledge. So today topic is Pharmaceutical Inorganic Chemistry MCQ series, your exam power boost. So Pharmaceutical Inorganic Chemistry PIC, in that today we are going to discuss about impurities in pharmaceuticals. Prepare, practice, succeed. So in impurities in pharmaceuticals, today we are going to discuss this topic. Under this topic, we are going to cover definition of impurities and importance of studying impurities. Next, sources of impurities in pharmaceuticals. Next, types of impurities. Common examples of drug impurities present in the active pharmaceutical ingredients and regulatory guidelines. So these topics we are going to cover. So first we will see the definitions of impurities and importance of studying impurities. So according to the International Council for Harmonization, so it's nothing but ICH. So ICH guidelines, it is present in the Q3A and Q3B. So impurities means any component of the drug substance that is not the desired product. So including starting materials, byproducts, intermediates, and degradation products and reagents. So that means other than the original product, if any other material like starting material, byproduct, intermediates, degradation products and reagents are present along with the active pharmaceutical ingredient, so that's all called as impurities. So according to the ICH guidelines, an impurities is defined as any foreign material present in a drug product only due to the contaminations. So that is called impurity. Any component of the drug substance that is not the chemical entity defined as the API. So other than API, any chemical substance are present, that is called impurities. A degradation product formed during storage only, so that is also type of impurities. And a residual solvents used in synthesis. So the residual solvent is one of the impurities for the API, active pharmaceutical ingredients. So the answer is option B is the answer. So any component of the drug substance that is not the chemical entity defined as the API. So this is the exact definitions for the impurities. So according to ICH guidelines, Q3A/B defines impurities as any component of the drug substance that is not the desired active ingredients, including degradation products and process residue. So the answer is exact and correct answer is option B. The study of impurities in pharmaceuticals is essential mainly to ensure. So the answer is option C. Safety, efficacy and quality of the drugs. So impurity profiling ensures the safety, efficacy and quality of pharmaceutical products and compliance with regulatory standards. Impurities profiling helps in all the following except. So except, note the word except. So the answer is option D. So increasing the solubility of API. So remaining all are, it's called impurity profile. Identifying degradation pathway, ensuring patient safety and detecting toxic residue. So these are all helps in impurity profiling except increasing the solubility of API, active pharmaceutical ingredients. So impurity profiling deals with purity, safety, not enhancing solubility of the API. So next we will discuss about impurities in pharmaceuticals, sources of impurities in pharmaceuticals. So there are several sources are there. First one is raw materials. So an example residual solvent we will use in the preparation of raw material like methanol and acetone, and manufacturing process. During manufacturing process, metal contamination from the equipment may occur as impurity. Byproduct. Byproduct means during the manufacturing of raw material. So in oxide in amine drugs. So when we are using amine drugs, there is the impurities may formed in the byproduct like N oxides. Intermediates. Intermediates is a esters intermediate in penicillin. During penicillin synthesis, so ester product may forms as an intermediate. Degradations and storage. So during degradation storage, the product may hydrolysis. For example, hydrolysis of aspirin during its storage. So that act as a impurities. An environmental factor. So dust and microbes. Due to dust and microbes, so it increase the impurities. Packaging. So packaging leachable from the PVC, polyvinyl chloride bottles. So this act as a impurities. And water. So waters from the water, there are so many minerals are there, especially heavy metals, and microbes act as a impurities. And human errors. Errors is a example, improper handling or cleaning of the containers or packing vessels. So that's act as a impurities. So this is a short note for the sources of impurities. So we move into the questions. The impurities originating from unreacted starting materials, reagents or solvents belongs to which source? So the answer is option B, raw materials. So impure or unreacted raw materials can introduce unwanted residues like solvents or reagents. Metal contamination in a drug product is most likely to occur from, so the answer is option C, manufacturing process. So equipment such as reactors or pipeline can leach metals like iron, nickel or copper during processing. So that's called metal contamination of impurities. Formation of N oxide as a side product in amine containing drugs represent impurities from, so the answer is option B, byproduct. So byproducts are unintended secondary products formed during synthesis. Unreacted intermediates in the final product are classified as, option C is the answer, intermediate impurities. So intermediate are compounds formed during synthesis that remains if reactions are incomplete. Dust and microbial contaminant introduced from the manufacturing area are examples of, so the answer is option B, environmental contamination. So these arises from an unclean manufacturing environment or cross contamination may occur. Leaching of plasticizer or dyes into a formulation from containers represents, so the answer is option A, packing impurities. So packing material can leach impurities especially from PVC or colored plastic. Presence of microbial or heavy metal contamination in process water indicate impurities from, option B, water used in production. Impure or unwanted water introduce chemicals and microbial impurities. Cross contamination due to improper cleaning or labeling is due to, so the answer is option A, human error. So human may do mistakes such as inadequate cleaning, lead to contaminations and mix up the two different drugs. Which of the following is not a common source of impurity in pharmaceuticals? So option C is the answer, pharmacological testing. So testing does not create impurities. So impurities arises during synthesis, processing and storage of the raw materials and drugs. Impurities due to degradation caused by light exposures are known as, so option B is the photolytic. So photolytic degradation occurs when light exposure breaks down the drug molecules. That means light sensitive drugs. So next we will discuss about types of impurities. So types of impurities. So first is organic types. There are 4 types: organic, inorganic, residual solvent and microbial impurities. So first, organic impurities formed during synthesis or degradation of the product. So example, unreacted intermediates and degradation products. Inorganic impurities occur from raw materials and reagent and catalyst. So example, heavy metals and inorganic salts. And residual impurities like volatile chemicals used in processing. Example, methanol and acetones. And microbial contaminations, contamination by bacteria or fungi. So example, endotoxins and pyrogens grow during the storage. Next, types of impurities based on the stage of formations. So in this slide, based on the origins, these are all the types of impurity. So now will discuss based on the stage of formations. So according to that, starting material. So types of impurities, starting material from raw material impurities. So example, impure precursors. So intermediate product due to incomplete reactions. Example, antibiotic intermediates. Byproducts formed in the side reaction. So example, isomers, rearranged products. Degradation it is occurred from storage or processing. Example, hydrolysis, oxidation products. Formulations, so API excipients interactions. So it is example, API active pharmaceutical ingredients and stabilizer complex formation. Packaging related, so it's leached from containers. Example, plasticizers and metal ions. And these are all enter into the impurity in the final products. Move into the questions. So organic impurities typically included all except. So the answer is option D, catalyst. So these are all included as a organic impurities except catalyst. Catalyst are inorganic or organic impurities come from reaction products and degradation products. Heavy metal residues are classified as, so option B is inorganic impurities. So metals like lead, iron and coppers are inorganic in nature. Residual solvents are regulated under which ICH guideline? So the answer is option C, Q3C. So in ICH guidelines, Q3C provides limit and classification of residual solvents. So residual solvent classes from 1 to 3. Microbial contaminant and endotoxins are examples of, option C is the correct answer, biological and microbial impurities. So these arise from microbial growth and are considered biological impurities. Leachables from plastic containers fall under which category? So option B is the correct answer, packaging and related impurities. So leachables migrate from packing into the formulations over time. So over time during storage. So next we will discuss about common examples of drug impurities. So these are all the very important examples. So they are asking repeatedly in the MRB and DA and GPAT questions. So by using these drugs as an impurity. For aspirin is a type of impurity salicylic acid. It's a sources of impurities like hydrolysis during storage conditions. So during storage conditions, salicylic acid formed. So in salicylic aspirin, active pharmaceutical ingredient. So like that, paracetamol, para-aminophenol is an impurity. It's formed due to incomplete reactions and degradation because para-aminophenol is a starting product of the manufacturing of paracetamol. Penicillin, so 6-amino penicillinic acid is used as an impurity. So it is sources is incomplete synthesis. So during penicillin synthesis, 6-amino penicillinic acid is the penicilloic acid is the starting material for the synthesis of penicillin. So due to incomplete reactions, this 6-APA is present as an impurity along with the penicillin. So next, chloramphenicol. So dichloroacetic acid is the impurity because it's formed during side reaction impurity. So during the side reactions, it may produce the dichloroacetic acid. And vitamin C, dehydroascorbic acid is the impurity. It's formed due to oxidation of the vitamin C. So during storage conditions, vitamin C get oxidized and it form the dehydroascorbic acid. It acts as impurity for the vitamin C, ascorbic acid. Moving to the questions. Salicylic acid is a degradation impurity of. So option C is the answer, aspirin. So aspirin hydrolyzes into salicylic acid and acetic acid in moisture. When it's presence of moisture, it hydrolyzes to salicylic acid and acetic acid. Para-aminophenol impurity is commonly found in. So answer option A is the answer, paracetamol. Para-aminophenol forms due to incomplete acetylation or degradation of paracetamol. 6-amino penicillinic acid impurity may occur in. Option B is the correct answer, penicillin. So 6-amino penicillinic acid is an intermediate and potential impurity in penicillin synthesis. Dichloroacetic acid impurity can arise in. So option A, chloramphenicol. So chloramphenicol synthesis involves chlorination step that may yield dichloroacetic acid. Dehydroascorbic acid impurity form due to oxidation of. Option C, B is the answer, vitamin C. So vitamin C is the ascorbic acid, oxidizes easily to dehydroascorbic acid. So next we will discuss about impurities in pharmaceutical regulatory guidelines. So major international standards for impurity control include. So ICH guidelines, Q3A is R2, impurities in new drug substance. ICH Q3B R2, impurities in new drug products. ICH in and ICH Q3B R2, impurities in new drug products. ICH Q3C, so residual solvents. And one more is missed, ICH Q3D. So it's the elemental impurities. And USP, impurities in drug substance and products. And WHTRS technical report series, guidelines for impurities in pharmaceuticals. We'll move to the questions. ICH Q3A guideline is related to. So the answer is option A, impurities in new drug substances. ICH Q3A specify impurity limits and identification requirements in API. ICH Q3B guideline refers to. So the answer is correct answer, option A, impurities in new drug products. So ICH Q3B deals with impurities found in finished drug formulation. So ICH-Q3C guideline classifies solvents into how many categories? So the answer is option B, 3. So ICH-Q3C divides solvent into class 1, class 2, class 3 based on toxicity and permissible limits. Next, USB more than 1086 and less than provides guidance on. So answer in the comment box. So all of you join in our WhatsApp community. You will get hands-out material and number of test series to check your knowledge. So thank you. Like, share and subscribe.